Alright, so hello everyone, welcome back to this amazing super video. It's been a while since I recorded anything, but as you can see, here I have a little bit of a code going. Don't mind this shitfest, it's a little bit bad. But the point is, this is a particle simulator, because in my Discord server, I've asked people, do they want to see a particle simulator that uses a compute shaders. Obviously, right now we don't see any compute shaders. I mean, I do have this bit of GLSL code, but that was like testing things, I've just been trying out the new ground. I was binding 3 buffers and I did multiplication. And so here I have single CPU simulation class, and it basically does exactly what it says, and it uses single CPU core to do simulation of the board class, the parent class. And basically, I don't know if I want to explain, but the point of this entire bloody mess is that theoretically, this thing should preserve every particle, and it should leave all the particles kind of independent-ish of each other, in a sense that we have a particle, right? We have just one particle, we focus on that particle, and we look around to find the other particles, and we basically just consider, okay, where do we move all things considered, like all the particles around it considered, you know?
You know, it's good shit when we whip out a camera. But basically, I'm gonna explain how my algorithm works, and I hope that this fucking pen will write, because before I did. So basically, we have a grid of particles, right? Let me draw a very shady grid. So, suppose we go ahead and check this particle right here. So, what happens? Basically, what we do is we check first, okay, do we have a particle right here? If we don't have a particle right here, then we're just gonna go down there, you know? If we don't have any particles, then we're just gonna move down safely and nothing bad will happen. However, if this particle is present, right, it exists, we cannot go here, can't do that. So, what we do next is we check all of these 4 particles right here, and right here. So, with that, what we do is, if we have either one of those particles, that means that we cannot go left. So if we're gonna attempt to go left, there's a chance that we'll merge with one of those, and we cannot go there, you know? Cannot go here. That's why we check if we have... So next we check if we have one of those particles, right? We're gonna want to try to go here, and for that we need to check those 2 particles. And if they are present, again, we cannot go, and the particle, this one, stays stationary. So, why do we have 2 particles that we check here, right? Why do we need to do that? Well, the thing is, because we're doing everything in parallel, we can assume safely that these particles, if they had free space here, if this space is like completely empty, then they probably already moved here, right? They're already present right here. That means we cannot move here. That's why we check these 2 particles. However, these 2 particles, we basically have a 50-50% chance. If we had a particle, we don't check these particles, but I'm just gonna mark them with a square or something. But basically, if we had one of those particles here, the point is, if we have this particle, it has a 50-50 probability. If it has this empty space and this empty space, then it's gonna move to one of those, because like we use some randomness. This particle can move here. If that happens, boom, problem. We moved into the particle and we have removed this particle. Oh no, that's bad. And the same goes for here. If it moved here, boom, we have a problem. We might have a collision. That's why we check for all of these 4 particles. We basically check the left, the 2 particles that are to the left of this particle that we're checking, and we test these 2 particles that are directly to the right of our particle, of our main particle. And that's basically how my algorithm works. And I think I haven't tested all cases, but in theory, it shouldn't fuck up. It does look slightly strange, I suppose. It does form a interesting pattern, but the point is, it does settle down and it does make a nice sand tower, which is exactly what we want. So this actually, the fuck is this? And that's how it works. It's very good. It's very fun. It works. It's functional. Amazing.
Okay, let's see if that's gonna be looking better. Oh yeah, that's looking much more solid. Look at that. That's a fucking particle. Okay, let's zoom out a little bit more. I'm curious how many more particles can we handle. Oh, I guess that's correct then? Oh yeah. Holy shit. Hey, I mean, it's running at 25 FPS, and look at this cursor go. It's just like... That's funny. Holy shit, look at the amount of particles, mate. That's funny. That's cool. Yeah, that's definitely worth it, right? It's worth something, right? It's good, you know? It's cool. It's amazing. Look at that. We have particles. Yeah, so that's what I've crafted in the last 2 days. I haven't started working right after I made the poll. Well, I say it's a poll, it's just like I asked, hey guys, do you want to see this shit? And you said, yeah, sure. So here's this shit. It works. Expect to see a compute version eventually. That's my favorite phrase, just, you know, eventually something will happen. And eventually this thing will be complete. And I'm gonna make it look good, because this is... The pixels... This is not square, this is rectangular pixel. Alright, well, I guess that's it. There we go. That's the particle simulator. It does things. See you next time. Goodbye.